Let me quickly go through the agenda. In the beginning, I'll speak about the global and Australian-wide initiatives in reducing carbon. And then we clarify what is operational and what is embodied carbon. And then Henrique will present ways how to reduce embodied carbon and how to make your project carbon zero or even net zero positive. So this is obviously a joke, but it's not a joke anymore that the climate is rapidly changing and we don't need to prove it. If we don't manage our resources wisely, we might not achieve Paris Agreement goals, and this would lead to a huge catastrophe. The manufacture of buildings, of building materials, or the carbon from building materials, or embodied carbon as we call it, contributes currently and worldwide to about 11% of total global greenhouse gas emissions. This 11% might sound insignificant. However, this is going to change in the future. What's happening in the world? So World Green Building Council created a project, global project. It's called Advancing Net Zero in 2016. And this project calls for 100% net zero carbon buildings by 2050, supported by about 15 green building councils in the world, including Australia. And originally, the definition of the net zero carbon building was a building that is highly energy efficient and 100% powered by renewables. So obviously, it looks only at operational carbon. And certainly it needed to be refined slightly since embodied impacts were not addressed properly. And as you probably know, this week we're celebrating 10th World Green Building Week, and World GBC has issued a brand new report this Monday, which is called Bringing Embodied Carbon Upfront, and I highly encourage you to download this report and have a look. This goal is to reduce embodied carbon emissions by 40% by 2030 and by 100% by 2050. As to Australian initiatives towards reducing carbon, we have National Carbon Offset Standard, NCOS. This is a voluntary standard to manage greenhouse gas emissions and to achieve carbon neutrality. So anything can achieve carbon neutrality, a project, a company, a product, a building, and so on. So you can also certify a building as carbon neutral using the following pathways. I won't go too much in detail, but basically they are in cooperation with Green Star Performance Pathway or with neighbors. Also, EPD Australasia participating to make building EPDs also compliant to NCOS. GBCA also announced this year developing new credits for new buildings. This will be published in 2020. And it also encourages look at embodied carbon more. So in the future, 5-star buildings will need to reduce embodied carbon by 10% and 6-star buildings by 20%. But we already covered this topic in a couple of webinars, and please have a look on following the links. We will distribute the presentation at the end. Now let us have a bit of more clarity on what is actually net zero carbon. There are different interpretations and definitions, and as you already heard, the World GBC definition of net zero carbon only accounts for operational energy impacts, but is it really enough? Shall we declare a building net zero carbon if it only looks at operational energy or not? It's a big question with no answer, but I would like now to explain briefly the difference between operational and embodied carbon in the building footprint. And in the following definitions, we make reference to the life cycle stages or modules defined in the widely adopted European standard EN 15978. And I would actually like to jump into the software to quickly show you what is operational and what is embodied carbon. So for those who didn't use our software yet, we've got, for example, here a reference building project, commercial building, and on the right side you have different impact categories, so global warming potential in this case. And as you can see, energy or operational energy contributes to the most of carbon. So it's about 10% in this case, or 90% in this case, or a bit less. So if we now think about different characteristics of the building and site attributes, certainly choosing the location of the building would make a difference. So if we, in this example, we're using New South Wales grid, but yeah, I'd like you to remember this number for energy, 148,000 of tons. If we would change here to Tasmanian grid, then the number will change. And this also means that we need to understand where the site is located and how carbon intense the grid is. As you can see, the energy is here much less because Tasmanian grid is already quite renewable focused. And we can also choose future grids here, for example. As you know, in the future, the grid will be less and less carbon intense. And if we look at the average assumption for this case, then this also needs to be calculated. So basically, the whole idea is to also focus on embodied impacts because their significance will increase in the future. From all the stages that this international standard looks at, so the manufacturing of materials, their transport, construction, the use phase, maintenance, repair, refurbishment, we can switch off these modules that account for operational carbon, so B6 and B7, and we can also switch off completely D module, which is benefits and loads, and look at only embodied carbon and look what it consists of. So now would like to speak about the embodied carbon, which is currently only about 11% worldwide, and the operational carbon is reducing, and also in other parts of the world, like in China and in Africa. And it's estimated that in the future, about half of total carbon emissions would also come from the embodied carbon. And that's why we definitely need to look at this in more detail. And why this is happening, so as you know, the operational emissions reducing due to global commitments, due to increased energy efficiency, due to improved regulations, technology advancements, and so on. And certainly we need to continue to focus on operational carbon, but also understand that the embodied impact will become more and more important. So now I would let Henrique continue the presentation and speak about the ways how to reduce embodied carbon.
Thanks, Maria. Hi, everyone. I'll just bring up a question here because it's quite common that when discussing about embodied carbon, we relate to materials. So that's the first correlation that comes to mind when talking about embodied carbon. But before we investigate where the embodied carbon impacts come from, where the project hotspots are, which materials, how about we talk about functionality? So this is often missed, forgotten at the early stage of a project design, and we found this really crucial part of applied LCA for reducing embodied impacts. So when talking about functionality and improving performance, we'll look at all the project's impact, and then we'll divide it by the primary function of that design. So if we're looking at commercial office, for example, we'll try to maximize the net lettable area, how much space we can provide for companies, for people to work at. If we're looking at a residential building, we'll look at providing shelter for people, how many occupants you can provide shelter to on this building, and then also how long this building will last. So looking at the impacts divided by year. And you can combine the functional unit as well. So maximizing both the occupancy as well as design life. So that dilutes your impacts just by increasing functionality. We're not talking about energy efficiency. We're not talking about materials. We're just talking about maximizing the primary function of the building. So usually, very often, when you're talking about embodied impacts, people associate with materials, as I said, credit to gate manufacturing. So all the module A, as Maryia mentioned, and then the transport of those materials to site. Then you depend on the transportation mode and the distances. Also the assembly, all the energy and equipment used during construction. The recurring impacts, they become very significant over time, and it's quite often forgotten as well, or not given proper attention. We have refrigerant gas, fit out like painting or carpet, floor finishes, they become very significant over time. And also we have the end of life impacts. So those are all the typical embodied impacts that you can improve on. But most importantly is the functional improvements, as I said, increasing design life, increasing occupancy, lettable area. If you're designing a warehouse, for example, what's the storage capacity? So you just have to identify the primary function of your design and try to use LCA to test different scenarios. We did, for example, we worked on a project. It was a public library. It was a civic center. And one of the key metrics we used was occupied hours, how long that building was occupied for. And we identified an opportunity to use the building during the weekend. So that was just by increasing the occupied hours, you would dilute all the impacts with construction and all the base loads that you have to operate that building. So it was just an interesting perspective when trying to calculate impacts and maximize the functionality, is using the functional unit concept. And most importantly, engaging early, test those scenarios prior to starting the design, so you can really set those targets early on, because that's when you have the most the biggest ability to influence improvements in the performance. As I said, when you're designing the build to last, you making a better use of the materials before demolition. There's less rebuilds over time, so there's less waste. less transportation impacts, and also all the construction and deconstruction impacts. So just building to last longer. Usually there's few factors that will affect design life. There's the structural integrity of the building, what it's made of and how long it lasts. So the quality of the materials and the type of materials, but also, and it's often the driving factor, is the redevelopment potential, the suburb density and economic influence, basically the land value, and then some aesthetics and design quality as well. So natural disaster is also a big factor that's playing more and more now. So buildings are adaptable to and resilient to last. When talking about redevelopment potential, building value, so it's what we talked about, density, increasing the building value compared to the land. So it's unlikely that you get the building knocked down for redevelopment. Timeless character for the site and surroundings, so the aesthetics of the building. And also designing for either retrofitting or deconstruction, depending on the application. So it's quite a hot topic at the moment as well, with the modular constructions and adaptable constructions to suit the purpose, you know. So we'll bring some more specific examples. For example, when we're discussing office functionality, you can have services, so bathrooms and common services shared between floors. If you have organizations sharing multiple floors on a building, you can look at what happens if you remove one of the lifts, you know, how much area you get with net lettable area you get. You're going to get a little bit of energy savings as well, but you're also increasing functionality, minimizing common area circulation ways and corridors, defining benchmark for the application as well. So in a commercial space, we look at number of workstations. This is quite interesting because if you consider hot desking, for example, where you have multiple various staff sharing the same workstation, then you even increasing functionality even more. If you look in on a per workstation or basis, there's often opportunities with the mezzanine to turn into lettable area as well, and optimizing car parks. So there's probably a whole webinar on this. So we're just bringing some ideas for consideration here. Car park is inherently high impact because all the embodied impact and also the maintenance, the ventilation, lighting is usually 24/7. So it's quite a big impact proportionally from an office building, and the efficiency is not as usually very high. So we have 30 to 40 square meters per car bay, and we've had projects bringing that down to 20 meters square. So it's just minimizing ramps and roadway and car parking, and also considering car sharing. You know, we've had projects reducing the car park by having electric cars, car bays for electric cars, shared car bays for electric cars. So that's becoming quite common as well. But when we go back to the hierarchy of carbon reduction, we first of all we try to eliminate. So is there a necessity to build? First of all, try to avoid construction, or try to optimize the construction so you need less columns or less piling or less volume on your foundation design. So that's about optimizing project. reducing the amount of material. So there's a few structural elements that we'll look into that, bubble deck or the post tension slabs. There's a lot to integrate with the structural engineers, and that's the interesting part about embodied analysis. Is the structural engineers are going to become a lot more their work is going to become a lot more valuable. People are going to give a lot more attention to what they're doing and how much impact is on the structural, the core and structure of the building. And then you have the most common things, which are to replace different materials, and at the end you will offset the remaining impacts. So that's the usual process to reduce embodied carbon. Let me show you just two quick examples in the software on how to reduce embodied impact, following from Maryya's example. When Maryia turned off the life cycle stages related with operational impacts, we saw there's a big reduction. So in this case here, I have 68,000 tons, but I will turn off the operational stages and also old module D stages, just to be left with the embodied impacts only. So now we're talking about 17,000 tons for this commercial building. There is one report where you run a top impacts report to help you understand the hotspots and where the impacts are coming from. So as a classic example, concrete and steel, we usually make the top 5, in this case, top 1 and 2. So we have concrete 40 MPa here that I will replace with 30% fly ash, and we'll also look at the steel impact. So out of that total 17,000, 5,000 tons is coming from concrete 40 MPa, then there's another 2,500 tons from concrete 50 MPa, and another 2,000 tons from steel. So these are quite intense carbon intensive materials. And then we have another feature in the software to test different scenarios. So I created another design here to show that quickly. So go to the bulk swap and replace the concrete elements. So we just need to filter and find the right elements that you try to replace. So I'll select all the 40 MPa poured concrete here. Just to make it simple, and then I'll change it to I'll change to 40 MPa 30% fly ash. 40 MPa, 30% fly ash. This one here, unreinforced concrete. I'll just add that to the design, and then the software will show us the savings. So we had originally 5,000 tons here, and then we drop it to 4,100 tons. So there's a 846 tons of carbon savings here just with this change in material. We can also use the same functionality to change recycled content of steel. So just got to find the the right material again, same process. And then I'll just try to find here that contains reinforcement. Okay, so now I have all the reinforcement bars used for concrete here, and then and you can see the recycled content. The world average is 40%, and if we have EPDs or self-declarations from manufacturers, we can change the recycled content, let's say, to 90%. So that's closed loop recycling. Still recycled steel being reintroduced in the production cycle. So then we have 400 tons of carbon saved with this strategy. So just very quickly show you, oops, how this is done in the software. Then we also have carbon storage materials. So it's becoming more and more common to replace those carbon intensive materials with materials that have the biogenic carbon. So they have carbon credits added to your design. We have cladding options, we have insulation options, even building fabric for walls and whole wall systems. So it's an area that's really exciting to see the advancements in technology and pricing as well, and also regulations, how they're meeting the requirements with regulations in terms of fire and performance, acoustics and thermal performance and all of that. So once we've reduced that embodied carbon, how do we get to zero carbon or carbon positive? So that's the next challenge that we are aiming, to become or regenerative design or carbon positive, where our buildings are enhancing the planet, and that includes all emission sources in the building life cycle. So this representation here is from that Advancing Net Zero program that Maryia mentioned earlier. What's happening today is focus on this blue area here, which is operating emissions, module B6. So all the integrated in the energy consumption. So that's the key focus on the net zero program that we're working on currently. And what is happening is we're trying to increase the scope to include all the building construction. So this orange area here, and also the other modules over the life cycle. So the use stages, end of life, and module D, so the carbon savings from material reuse. What we've found is you have different methods to achieve that carbon positive, and I'll show you again in the software one quick example with operational energy exports. So when you have a large solar PV system and you're creating more electricity than you need, you can export that back to the grid and create carbon credits for your design. So what I've done in this example is I added a template here for the solar PV. So in this case, I'm assuming that all the operational energy have already been neutralized, either with energy efficiency or a different PV system. So this PV system is now brought into the project to provide further savings. So when you look at the overall, I have to turn this back on again, the operational lifecycle modules. So like we can look at the integration of energy exports. I'll I'll turn off or I'll turn on the Z module as well. So looking at a PV system on its own, this is a 150 kilowatt PV system, so quite a large system for a commercial project. And you can see this template would take into account the embodied impacts with the system itself. So you have the inverter, the panels, the installation, and the replacement over time, over 60 years. So it's the red recurring impacts, the replacement, and the orange product impact is the initial installation. So those are the embodied impacts, but then you have the other, which is the energy exports here. You see some of the energy is used to offset the embodied impact from the PV system, but then we have almost 2,000 tons here that can be used as a credit to offset remaining emissions from the project. So remaining emissions from materials or from the other embodied impacts. So using energy export is one option to reduce or neutralize emissions even further. And the other example I have here is carbon offset. So how to use carbon offset for the remaining impacts, and also how much does it cost. Maryia mentioned also earlier about innovation credit in Green Star, where you get points for offsetting your embodied impacts. But depending on the project, depending on the design and the materials, it can become very expensive. So I'll just show you in this example the whole total embodied impacts, even after compensating all the operational impacts, reducing all the operational impacts, using the energy exports to reduce even further. We ended up with 15,000 tons. So 15,000 tons, if we consider $5 per ton of carbon to offset, we're talking about $75,000. So it's quite expensive to offset the remaining emissions for this building. So what companies are looking at? They are looking at specific scope from the overall remaining impacts and try to tackle in stages, So from the overall embodied impact, the majority of the impacts are here in this module A, so the product and the construction, the transportation and construction. So companies are now looking at offsetting life cycle stage A first as a next initiative after net zero operating emissions. And then as we develop more data and more accuracy on maintenance and replacement and end of life, it will become easier for companies to include this as well. So we see from the projects that we're working on, operating emissions is the #1 priority. After that is reducing embodied carbon through materials and energy exports, energy exports, and then we see the module A, carbon offset, as the next thing that will happen, from companies implementing their plan and their strategy to meet Paris Agreement following a national target.